In this lesson, we'll be taking a quick look at how to calculate percent composition for a compound. The percent composition is described as the percentage by mass of each atom or ion that makes up a chemical compound. The compound known as hydrogen peroxide has a formula of H2O2. You can see that it has the same number of hydrogen atoms as oxygen atoms. However, this does not mean that 50% of the compound is made up of hydrogen and 50% is made up of oxygen when we consider the mass. This is because the mass of oxygen is much heavier than hydrogen. Let's take a look at how to calculate percent composition. The first thing to do would be consider the elements that make up the compound. In this case, we have the elements hydrogen and the elements oxygen. Next, we look at the quantity of each. There are 2 hydrogen and 2 oxygen described by the subscripts, or the small numbers in the formula. Then we would look at the periodic table to find the atomic mass from each element. I like to use the exact number from the periodic table to get more accurate results. Looking up hydrogen, we see it has a mass of 1.01, oxygen a mass of 16. Then we have to account for the fact that there are more than one of each atom, so we multiply the number of atoms by the atomic mass for each. By adding these, we get what we would know as the formula mass, sometimes also known as the molar mass for the compound. The formula mass is the whole to compare the parts to calculate percentages. Since the part from hydrogen is 2.02, we would divide that by the formula mass, 34.02, and multiply by 100 to get the percentage of hydrogen. Likewise, we would do the same for oxygen. The total mass contribution from oxygen would be 32 out of a total of 34.02, multiplied by 100 to get the percentage of oxygen. You can see that we arrive at 5.93% for hydrogen and 94.06% for oxygen. Again, the reason the oxygen is much higher in percentage has to do with the mass of an oxygen atom compared to hydrogen being much higher. Let's look at one more example with a little more complexity. In this example, we're going to look at the compound known as aluminum sulfate for our example. Again, let's break down the elements that make up this particular compound. In this case, we have aluminum, sulfur, and oxygen atoms. For aluminum, we can see there are 2 atoms. For sulfur, since the sulfur is inside the parentheses and there is a 3 outside the parentheses, this is similar to distributive property. Therefore, 3 would be multiplied by everything inside the parentheses, creating 3 sulfur and 12 oxygen. Next, we would look up the atomic mass for each element from the periodic table. Then we multiply. The sum of each of these then becomes the formula mass, or the whole that we compare the parts to. By comparing the parts from aluminum, sulfur, and oxygen to the formula mass of 342.17 units of mass, we'll arrive at the percentages of aluminum, sulfur, and oxygen. When looking at the parts to compare to the whole, we can see that there's going to be a higher percentage of oxygen because the mass is higher than any of the other masses. Our formula mass reveals the percentages: 15.77% aluminum, 28.12% sulfur, and 56.11% oxygen. This simple procedure can be applied to the formula for any compound to determine the percent composition of the elements or ions that make up a chemical compound.